I'm going to go over the ACT additional practice for geometry. So let's get started. Number one, you have an isosceles triangle, and they tell you that one leg is 10, and they want you to find AC, which happens to be the hypotenuse. They're testing two things here. First of all, they're testing that you know the meaning of isosceles, that the two legs are the same. So this one will also have to be 10. Then you can either put into Pythagorean theorem and do 10 squared plus 10 squared is equal to x squared and solve it that way. Or you can remember that this would be a 45, 45, 90. Either way, the hypotenuse is going to end up being 10 times the square root of 2, which is choice E. Second one, you have a perimeter of a parallelogram of 72 inches. One side measures 12 inches. What are the length in inches of the other three sides? So I'm going to sketch a parallelogram. And if you don't remember your properties of parallelograms, they are down here, that the opposite sides are congruent. So if one side is 12, that means the other side has to be 12. So I'm going to write the other side green. So I remember that that's the side that I found. So the perimeter is equal to 2 times the length plus 2 times the width. So 72 is equal to 2 times 12 plus 2w. So 72 is equal to 24 plus 2w. Keep on solving for w, and you get w to equal 24. Sorry about that writing there. So you get w to equal 24. So this side is 24, and this side is 24. The question is asking for what are the lengths and inches of the other three sides. Be careful that you only write the 12 once and the 24 two times, and that would be choice C. The next one, it tells you that Meg pounded a stake into the ground. So here's the stake in the ground. The leash is 9 feet, which means that dog can travel in a circle. And it wants to know what is the square, what is the area in square feet that the dog can reach. So the radius of my circle happens to be that 9 feet for the leash. So my area is going to be pi r squared. So in this case, it's going to be pi 9 squared. They told me to use 3.14 for pi, multiplying that times 81, and I end up with 254.34. Looking at my answers, that's going to be choice D. Okay, the next one. It says the pentagon shown below, the measure of angle A is 50 degrees. It wants to find the sum of the measure of the other angles. So you can either remember this formula down here where the interior measure is n minus 2 times 180, or you can just start drawing triangles. And if I start pick a vertex, let's say E, I could draw triangles, and I can see that I have 1, 2, 3 triangles. Either way, I'm going to take 3 times 180. If I would have done the number of sides, I would have done 5 minus 2 times 180. Still going to get that 3 times 180, which will end up being 540. Now subtract the 50 degrees that A is, and my remaining angles happen to be 490 degrees, which is choice K. The next one, it says the figure below, it tells you that AD is perpendicular to BD and AC is perpendicular to BC. So that's marking these two right angles here and here. And AD is congruent to BC. Which of the following congruencies is not necessarily true? Well, I'm going to remember, if I look at this, I can see that AC congruent to BD, AC congruent to BD, that's going to be true because of the hypotenuse leg theorem. AD congruent to AE, they're trying to say AD, they're trying to say AD congruent to DE. I don't think that one's true. I'll come back to that one. AE is congruent to BE. That would be true because of angle, side. Angle DAB is congruent to BAC. That would also be those two right triangles, the hypotenuse leg. And so would this last one be hypotenuse leg. So the only one that I cannot assume is true would be the letter G. Okay, the next one, number 6. If I can get it to turn. Number 6, in the figure below, A, D, B, and G are collinear. If the measure of angle CAD, so the measure of angle that CAD is 76 degrees, that's 7, and the angle BCD is 47 degrees, and angle CBG, this angle here, is 140 degrees. What in degree is angle ACD? So now I'm looking for this angle right here. That's what I'm looking for. Well, there's two ways I can do this. One way is I could just start sort of working my way around the triangle. So if I do this, if this is 140 degrees, that means this angle here has to be 40 degrees because they're supplementary angles. So then I have this 47 and this 40. So this triangle here has to have angles that add up to 180, which means that this angle right here has to be 73 degrees. If that angle is 73 degrees, then this little guy right in here, well, he's not that little, he has to be 87 degrees. So because these two have, this angle here and this angle here have to add up to 180, which leaves this angle to be 17 degrees. I could do it that way, or I could remember that the sum of the two interior angles is equal to the exterior angle, so that 76 and this angle here, 47, 17, have to add up to the 140. Either way, I get H, which is 17 degrees. The next one, number 7, it says the parallel sides of an isosceles trapring shown below are 10 feet and 16 feet long, respectively. What is the distance in feet between these two sides? So it's looking for this. It's looking for this length right here. And I probably would draw a perpendicular. And if I do draw a perpendicular, I see that from here to here is 10. These two triangles here have to be congruent, which means that I have 6 feet left over. So 3 would have to go here, 3 would have to go here, which would give me the 16 feet because this is 10. And if this is 5, they form a right angle. That means it has to be a 3, 4, 5 triangle, which means the height is 4, which is choice B. The next one, it says in the figure below, line L is parallel to line M. Transversal T and U intersect at point A on line L and intersect M at points C and B, respectively. Point X is on M. The measure of angle ACX is 130 degrees, and the measure of angle BAC is 80 degrees. And it's all marked there. I mean, I still like to read it, but you don't really have to. How many of the angles formed by rays L, M, and T have a measure of 50 degrees? So now you're just going to sort of start going around and counting the angles that are 50 degrees. So if these two lines are parallel cut by the transversal, then these two angles are going to be congruent. This is going to be 80 degrees, which means that this angle here has to be 50. This angle here has to be 50 because they form that supplementary angle. This is going to be 50. And this is going to be 50 because they're vertical angles with each other. Then when I come down here, I have the two parallel lines cut by the transversal. The alternate interior are going to be the same. So that will be 50 degrees. And this one will be 50 degrees. And then I'm going to do the vertical angles with them. So now I'm going to count how many I have. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have C, which is 8. Number 9, in the square ABCD shown below, D is the midpoint of CE. So I'm going to write myself a little note, mark those. Which of the following is the ratio of the area of triangle ADE to the area of triangle ADB? ADE to triangle ADB. This triangle here. So when I look at this triangle, which I'm going to now color this one, the smaller one, I'm going to color this one yellow. When I look at this one, because of the way my sides are and the midpoint, I know that my base is going to be x divided by 2 because it's half, since it's the midpoint. I'm trying to get my pen back. So I know that this, sorry about that. So this side here will be x over 2. And then this side here is x. So the area of triangle, that's a triangle, ADE is going to be 1/2 the base, which is x over 2, times the height, which is x. So that's going to end up being x squared over 4. Now, when I do the area of the larger triangle, this triangle here, I'm putting those together, I can see that the area of that triangle, triangle ADB, is going to be 1/2 x, which is the base, times x, which is also the height. So that's going to be x squared over 2. So if I want to find the ratio, I can see that this one is going to be twice as large as that one. So my ratio is going to be 1:2. Sergio plans to paint 4 walls in his room with 1 coat of paint. The walls are rectangular, and according to his measurement, each wall is 10 feet by 15 feet. I'm writing myself a note. He will not need to paint the single 3-foot by 5-foot rectangular window in his room. So first of all, I'm going to do the 4 walls first of all, why I'm thinking of this, which are 10 by 15, and I have 4 of them, so I'm going to multiply all of those together, and I end up with 600 feet squared. He does not have to paint the window, so the window is 3 by 5 feet, and there's only one of those, so I'm going to subtract 15 square feet. And the 3.5 by 7-foot rectangular door. So I'm going to subtract that door. So the door is 3.5 by 7 feet. So I'm also subtracting that door, which is 24.5 feet. So when I do all that, I end up with 560.5 feet squared that I have to paint. Sergio knows that each gallon of paint covers between 300 and 350. If only 1 gallon cans of paint are available, which of the following is the minimum number of cans of paint that Sergio needs to buy? Well, I'm going to take the 560 that I have, 0.5 feet squared. That looks really messy, and I'm sorry. I'm going to divide that by, and I'm going to divide it by the smaller one just to be on the safe side, the 300. And when I do that, it ends up being 1 point something, so I'm going to need 2 cans of paint, which is choice G. Number 11, in the figure below, where triangle ABC is congruent to triangle KLM, lengths are given in centimeters. What is the perimeter in centimeters of triangle ABC? So I have this ratio, because they're similar, of 3 to 7.5. So I'm going to set up a ratio of 3 to 7.5. Then if I want to find, let's say, this side here, I'm going to compare it to 12.5. When my ratio, the smaller triangle's on top, the larger triangle's on bottom. So I'm going to we'll call this x for the time being. So I'm going to have x over 12.5. when I do that, you know what, I just stopped myself because I was going to find each side, but there's a more efficient way to do it. So what I'm going to do is I'm going to find the perimeter of this larger triangle. I'm still going to use that ratio. Oh, I shouldn't have erased the small and large, but I did. I'm still going to use the ratio of 3 to 7.5 because that is my ratio. But when I go to do this, I'm going to find the perimeter of this larger triangle. So I'm going to say the perimeter is equal to 12.5 plus 15 plus 7.5, and I get a perimeter of 35. And so then I'm going to set the perimeter of 35, which is the larger one down here, and then I'm going to cross multiply, and I'm going to end up with x equal 14. So the perimeter of the smaller one is 14. I could have gotten the same answer by finding x and finding y, but this way is a lot more efficient. So the next one, oh, we went the wrong direction. We don't want to go back to Sergio. All right, I have a right cylinder, which is shown below with the dimensions given. What is the total surface area of the cylinder? And notice they give you the formula, which is extremely helpful. So it's going to, so I'm going to say 2 pi, my radius, since my diameter is 20, my radius will be 10. So this will be times 10 squared plus 2 pi, my radius is 10, and my height is 20. And that's going to equal my surface area. I see that all these answers here have pi, so I'm going to leave pi in there. And so I'm going to have 10 squared, which is 100, so this will be 200 pi, plus 10 times 20 times 2 will be 400 pi. And I end up with a surface area of 600 pi, which is choice D. Okay, moving on to 13. For the right triangle KLM below, what is the sign of M? So hopefully you're remembering SOHCAHTOA. So it wants the sign of, what is the sign of M? So I'm looking here. And the sign is the opposite over the hypotenuse. So I need to find this opposite side first before I can do anything. That's the hypotenuse. So if I do that, I'm going to say 10 squared plus, we'll call it x squared, is equal to 12 squared. And when I solve that, I end up x squared is equal to 44. So x is equal to the square root of 44. I'm going to leave it like that. And the reason why I'm going to leave it like that is I see the square root of 44 over there. They did not simplify it. So then the sign of M is going to be the opposite, which is the square root of 44 over the hypotenuse, which is 12, which happens to be choice K. The next one, number 14. The isosceles trapezoid ABCD, AB is parallel to DC, and the measure of angle BDC is 25 degrees, and the measure of angle BCA is 35 degrees. What is the measure of angle DBC? DBC. So this is what they're looking for, this angle right here. So if this is 25 degrees, then, and I have these parallel lines, then I know that this is 25 degrees because there are two parallel lines cut by transversal. And since this side is congruent to this side, I'm going to end up finding that this angle here is also 35 degrees. And I'm going to take, so if I have these, I'm looking for this angle right here. I'm looking for this angle right here. So I'm going to end up, okay, the way I would do it is that this angle also down here also has to be, because these two angles down here are congruent. So this angle here is also going to have to be 25 degrees. So if I looked at this triangle here, these two would be 50 degrees, which means 180 minus 50 degrees is 130 degrees. 130 degrees, which means this angle here is 50 degrees because they're supplementary angles. And so then I'm going to take 180 and subtract 35 degrees plus 50 degrees, and I'm going to end up with B, which is 95 degrees. And the last one, number 15, in the circle shown below, M is the center, and the lines are U and ST. Which of the following statements is not true? So the first saying that the measure of angle TUM measures 65 degrees. TUM. And now that is going to be true because TUM is half of 130, so that is true. That will be. TU is parallel to RS. That's also true. TXU, so this segment TXU is 50 degrees. Yes, that's true. I'm just going to put a check for yes. RM is congruent to TM. So RM is congruent to TM. Well, yeah, that has to be true. So that's, and then the last one is RS is congruent to SM. So they're saying RS is congruent to SM. And that one is the one that is not true. So that is choice K. And here are some things that you're supposed to remember. The arc measure of a chord are determined by the central angles, and the sum of interior angles of a triangle are always 180 degrees. So I hope this helps you with the ACT, and best of luck.